Hi everyone, very good evening. Today's topic for this NashKnolx session is like best practices using Project Loom in any enterprise application. I think this is a very new term for all of us as it is introduced in the Java 19, but many of us don't use this technology in our current projects because it is mainly concerned to the core Java concept. So we are hardly using core Java in our day-to-day life because we are going through the Spring Boot. But when it comes to the bigger applications, which are the enterprise application, which are using mainly multi-threading concept or Java concurrency concept. So there we come with the term as a Project Loom. So we all of has heard about the loom. Loom is like what we call as a karga in Hindi. Like in that we just weave the threads basically, which Gandhi used to do. So like this, from there only this word has been taken, loom, and by using looms means like multiple threads, we are weaving our project basically. So this was introduced in Java 19 basically. So before going to the further knowledge, I've just these are the basic etiquettes for following up for any session, like punctuality, join the session 5 minutes before, feedback, which is very much necessary for the improvement part, as well as the things which can be added or maybe removed from the presentation or maybe for the further use also. And of course, we all have to be on the silent mode and avoid disturbance as well. And so today in this session, we will be covering these concepts like what is the basically Project Loom and what are the core concepts for it. And if I talk about the enterprise application, what kind of use cases where we can go with the use of the Project Loom, and how can we integrate Loom into the existing application, because we all know that we are going through the previous traditional threading, multi-threading mechanism where we are just extending the thread class or implementing the enable interface and creating threads and using multi-threading programming in handling the concurrency concept. So how we can integrate in our existing application, how we can monitor and debug the threads basically if it is in a multi-threading environment. So if it comes to the Project Loom part, how we can monitor and debugging those things. So maybe there are certain tools for that. So we will talk about that later. So of course, if something is coming as a new, it comes with the challenges and the pitfalls. So for this also, we are having some of the challenges and pitfalls also. Uh, since it is introduced in Java 19, so what will be the future of Project Loom for the bigger applications? And in last, we will have the demo, and then I will take up the question and answer for it. So what is a Project Loom? So here you can see in the picture, like there is a loom kind of thing. So we are having multiple threads there. So for simplifying the Java application, which are using the multi-threading concept, where we are having multiple tasks and which are being managed by which used to be manage multiple tasks at the same time. So in that concept, we have just come with the concept of Project Loom, and basically in the Project Loom we use a terminology called as a virtual thread. Earlier we were normally using the thread as we used to write as thread t equals to new thread, or we are extending the threadable class. But here we call this term as a virtual threads, means threads which are not visible to us, which are just running in the backend. Basically these are very lightweight alternative threads. And so previously threads were managed by the OS operating system. So which resource will be allocated to a particular thread, all these things, which how much memory should be allocated to a thread, was managed by a operating system. But in Project Loom terminology, as we use virtual threads, so it is managed by JVM, Java Virtual Machine. So there is no headache on the operating system for managing these things. This is the best part of this Project Loom. And for the key objective is like why this was introduced by for handling the high throughput in workloads. Basically, if there are lots of multiple tasks together, then of course as of now we are using multi-threading, but there are some drawbacks for that. So we came with this concept of Project Loom. And target audience means like suppose there is a bigger application which is just calling another application service classes also. So there are multiple parallel tasks are happening together. So handling such kind of applications, we come with the concept of Project Loom, bigger for the bigger enterprise applications. As of now, any questions for me? Okay. So, like, why the Project Loom matters basically. So, as you can see in the diagram, we are for the each CPU. So we are having multiple CPUs here. Like this is a distributed programming. So per CPU is having one CPU is handling multiple threads. Here also CPU has multiple threads. Like this is a resource and traditional threads basically are the resource intensive. So we have heard about the things like deadlock will be there. So means one thread can just hold one resource and waiting for the another resource to be get free. So these kind of traditional resource were occupying the memory and the space in the much more manner. So it was a headache on the CPU part basically. So because if one resource is held by one thread, then other threads has to be gone into the waiting state, and operating system will be managing all those things, and that just reduce the capability of the CPU for running other things also. And when we talk about asynchronous programming, so it is complex and error prone. Means like suppose I'm just trying to make a banking application, and I just want to implement okay multi-threading. One thread is using to deposit money into the bank, and another thread is doing withdrawal. So at the same time, asynchronous programming is happening. So we have to make sure the particular one thread is completed, then only other thread will be executed. These managing things will it is manageable, of course. As of now, we are just continuing with the traditional threading method, but we have to just write a wait, sleep. We have to handle. Yeah. Any question? Okay. So we have to just handle those things, but it is manageable, but it is become very complex for it will become very complex for an application to handling such thing. But for the looms, we just come with the virtual thread concept, which is handled by the JVM. So in this internally what happens in the virtual threading, each thread is not allocated a resource. Once a thread take a resource, if it is free for some time for waiting for another thing, it releases the resource. So there can be a thousands of virtual threads in a machine. Means one thread can be have thousands of threads. If one thread is holding one particular resource and waiting for another, it should release the holding resource already. So it just minimize the overhead. And all these things are managed by not by the operating system, with the JVM. So the performance of the system is not reduced basically, and it simplifies the concurrency while retaining familiar paradigm. Means like if we are writing this on concurrency thing, so we have no need to put the sleep and wait again and again for each and everything. So, okay, one thread is holding resource, it has to wait, then it will go to the sleep state, try catch, all these things, because it's Loom internally handle all these things basically by the JVM. So actually, this is a comparison basically virtual threads versus traditional threads. So I already talked about the traditional threads, like it's a heavy OS managed threads. Means like operating system is managing all the threads, and if you see internal justification for a thread, one thread is occupying around 1 MB of memory. So suppose I'm having 1,000 thread with us, and it will be lots. It will be holding a lot of memory of the system. And if I have to just to release a memory, so it will be if I'm having more than 1,000 threads, so it will be a out of memory error for me for creating multiple threads. So it comes under the limited scalability, because I can create a number. It is defined by the operating system. Okay, you can create only 1,000 number of threads in a particular program. Otherwise, it will throw out of memory error for us. So like this, it is having the limited scalability. But in the virtual thread system, I already told you that it is a lightweight, and we can create thousands of threads together which can run simultaneously. and there will be no blocking system. Means like one thread has not to wait for other to release the resource. Um, so I just take a layman example here. If I talk about the traditional thread, I just go to a room and I held a chair. I don't want to leave my chair until I get another chair for me, because I have to just make sure, okay, I'm already holding the chair. But in the virtual thread concept, if I talk about the linearity, if I'm holding a chair and waiting for another, I have to release my first chair, my chair on which I'm already sitting. So the simultaneous, so that particular chair can be occupied by another thread. So these things we have no need to worry about these things. Okay, how it is happening, how one thread is taken away and another thread, how resources are taken away from one thread and assigned to another one. So all these things will be taken by the JVM itself. So here in the diagram also, you can see that it's like a lightweight and scalable. We can just have number of scalable means we can just have number of threads, thousands of lakhs of threads in a particular program, and it enhance the concurrency means multiple threads can run together, and it is detached from the OS thread means there is no kind of connection of OS thread and JVM thread basically. So there will be no overhead on the CPU basically. And optimized resource utilization that I already explained, that it is not holding a particular resource. So we can just optimize. We can just optimize resource very wisely for our application. I'm just talking about the same thing again, like benefits of Project Loom in enterprise. It simplifies the concrete programming. Like we have to just, as you can see earlier on the traditional sync programming, we have to just write the compatible future. And here you can see it is a kind of a functional programming. We are calling a function supply a sync that is fetching the data, then we are applying and data and processing. But with Loom, we have no need to learn about the functional programming. Okay, we have to write method like this, then calling the method, then applying on that. We have just create a variable of fetch data that is already defined method, fetch data, and we can just process that data. So it because in between you can see in before Java 19 or maybe with Java 19 also, we are more focused on the functional programming. But somehow for a new developer or someone new joinee is there, or who has not worked on the functional programming, it's become difficult for them to understand the flow. Okay, from there this function is coming. How come we are writing all these things? But when we are coming with a trend of okay, writing a function, then calling it, then calling again with this another object or variable, it become easy for us. So virtual thread concept will came with such kind of implementation. We have to just define the data and we can just process our data through that. And its second part, it support high throughput application like microservices. Throughput, what is throughput basically? So if in context of an application, throughput means in a particular given time, how much data it is producing, or how efficient is our application. Means what kind of output is giving to a particular given period. Means like a bandwidth. If we talk about the in our daily life, it's a kind of bandwidth. If in my office hours, how much productivity I'm giving to a company, to the company, how much I'm doing in a particular project, or if a task is assigned to me, how much I'm optimizing the time, and how much of the project deliverables I have given to my manager, or my senior. So this is a kind of a throughput. So in this term of the Project Loom also, we just have the high throughput applications, like which are having multiple microservices, and we need multiple threads to manage those things for performing multiple tasks. So the example comes from the bank itself for me, like in a particular time, maybe if it is a big bank, thousands of users may be depositing the money, or maybe someone is withdrawing from the ATM. At the same time, managing all these things for a particular user or maybe multiple users become easy for managing these things. It is done by the traditional threads also, but there is a overhead for the CPU, and the system performance go down basically. And if I already talked about reduced resource consumption, enabling better hardware utilization. So if I talk about the traditional thing, so traditional threading, it is using the fixed stack size of default 1 MB per thread. basically. So suppose if there are 1,000 thread, there'll be the 1,000 MB memory for the CPU. Suppose if your system is already having less memory size and or an application is running to your system, of course your system will go down. And managing these things by CPU will become difficult and our application will not work properly. And but if we talk about the Project Loom, in there virtual threads are there, so the memory is allocated by lazily. Lazily means okay, whenever necessary, assign the memory to it. Okay, one thread is needing the memory assigned to this. If thread work is done, we have to just release the memory. So all these things are basically managed by the JVM only, but we have to just write the code and all these things are done. So we can create number of threads. We have no need to define the limit for creating the thread. And in the previous example only, I just talk about the readability and maintainability of the code. Means if I have written because if you see in a project, if someone new is coming and they have to just okay, 5 days time is given to them. They have to just read the code, understand it, and implement a new microservice. So if I have written in the functional programming, I'm waiting here and there. One thread is coming like this, and the functional programming is there. Lots of part is there. It's become difficult for them. So this example is already there. So it in this easy way we can just handle the miss, like the developer can understand the thing and implement the future part of the application. And if I talk about the use cases, in which field basically we can just use this Project Loom, the virtual thread concept. So if we talk about the web servers, so we all know what is a web server. It's like if there is a server which is hosting the request to us. So web servers are handling thousands of requests of client in a day, in a minute basically. Sometimes if means like you talk about any website like facebook.com, so you can see at a time multiple thousands of users are clicking on okay www.facebook.com. So on that server multiple requests are getting hit. So for managing those things we have to just we can just go with the Project Loom. I know this thing that as of now it is not implemented in the bigger applications, but somehow slowly it is taking place in each and every application. They are just going away with the traditional threading method. In the Flipkart, you can see they are going away with the traditional threading method. I have seen one article there that they are just going with the virtual thread concept. So if something is happening fast with some new enhancement and the easy return of the code, of course people will switch to that particular technology or particular new change basically. So for the web servers, it is very much helpful, and database access. So uh, we can see that for the database also, if something is getting loaded to our application, of course it is coming from our database only, from particular database only. So we are hitting our data for a particular, maybe this database on the server or maybe on the client side, it is just getting hit in a time, maybe 1,000 times, 2,000 times. So it's become tough for managing database access also. So in that term also we can use the Project Loom. And I already explained about the microservices. There are like 1,000 of microservices in a bigger application. So we have to perform multiple tasks together for making the application efficient. Suppose data is getting loaded or in some other function, we have to just print the value, or maybe we have to just send the data to another. Maybe in the Kafka only we have to send the data. We have to just notify another application. Okay, this data has been produced, and this should happen in the same time. Otherwise, the user will lose the data. I just give an example. That is a real-time example. Suppose we are traveling in a ship, and in between of the travel, we have just done some booking for the hotel. But since there is a network issue from our end, and the data is, we have done the booking successfully, the network is come properly, but at the same time, it was not sent to the recipient application. So the data loss will be there. So in such case, we have to make the application fast, and the same time, it should be asynchronously update the another database for the hotel also, so that user will have a good experience. Okay, this your hotel has been booked, there is not a pending request, or you have to just okay go by the trip and relax in the hotel like this. So these kind of things managed by the threading concept only. And last we come with the batch processing. Batch processing example, if I talk about, is like a handling task with the minimum scale the task handling with the minimal resource impact. So you can take example of like data migration. Suppose there is an application which is using Oracle database, but now they want to make a new application, and they are just their demand. Okay, we have to just deploy our data to GCP now, not the Oracle. You have to just use a Google Cloud storage for storing our data. So in such cases, we can't just okay copy paste the tables. We can't just move one by one. There will be data loss or data discrepancy will be there. So in such cases, we can take help of the this virtual thread concept. Okay, one thread is doing with the writing in the table, and another thread is loading the views, schemas, and everything. So these helps in the batch processing also, means like ETL extract, transfer, and loading the operations basically. So suppose in the last example, you in the C you can see there is a variable of files, file 1, file 2, and file 3, and we are just parallelly processing. There is a parallel stream for the each file, and it is reading from the file, and it is going the output. So here each file will be having its own virtual thread, allowing efficient handling of hundreds or thousands of files. Means in this case we can handle multiple files together. There is see, you can see in the code I have nowhere written sleep or wait. Okay, this file is completed, then you have to sleep for this much time, you have to wait for such this much of time, then only you can continue with another file. No, we can directly process with all file together. We have no need to managing all those things. JVM will handle those things basically. So this is a diagram which is just defining the edge cases. This is a like enterprise application use cases. I already talked about. There is a web server handling, efficient database handling. There are thousands of connection together. So how does it manage? Nowadays it is managed by the traditional multi-threading concept only, but the virtual threading will help us to make it faster basically. And in the scalable microservices, batch processing task, high concurrency of connection, thousands of connections are there, efficient database handling, efficient DDO space basically. So these are the edge cases for in a bigger application basically. So if you are seen in some organization, product based companies basically, there is a bigger project of which is running from maybe 10 10 20 years. So in that case it has become a vast project, it has become an enterprise application. So in those things, they just whenever new things come, they just take the technology and they just implement the things slowly to their application. So if I want to use Project Loom in my application, so what should I do? I have to just understand the virtual thread behavior, how they are just interacting with the I operation and the thread pools. Basically, there is a no concept of thread pool like which is in the traditional threads. Okay, only okay we can take from the thread pool. We have to maintain the thread pool. Then executor will be there that will be assigning the number of threads. Like this, there is no concept of there. There is a normal creating the thousands of threads, and avoid overusing thread locals. So earlier, whenever needed, we used to just create a variable of the thread locals. But here, we have just create the thread. We have no need to create the thread locals variable. We can just create them as per the need only. And there is a method of removing that also, dot remove. So by that, it is just remove the thread local variable. But previously, it will be done by the garbage collector. Okay, thread local has completed the work. Now garbage collector will pick up for the removal of that particular thread. But here we have just multiple methods for releasing the memory and optimize the thread scheduling. Even though I told you that thread scheduling managed by the JVM only, but somehow if we are making an application, we want to make sure to our satisfaction also. Okay, our application should behave in a proper scheduling method. So we can use the structure concurrency APIs to manage the task hierarchy. Okay, this task will be performed first. These are the priorities of a particular microservice, and other were the less priority. So by using that hierarchy only, we should make our application. Because I told you that even though it is already handling all such thing, but But if I want to make a good application, or like application which is running in a bigger environment, I should take care of such thing also. And test of the scalability, we have to just regular benchmark and monitor application, okay, how they are performing, how are they scalable or not. So these kind of tests should be performed there. We are have Project Loom has introduced multiple monitoring tools for monitoring such other threads also. And in the legacy application, how the Project Loom is integrating basically. Nowadays, if my application is running with the traditional threading method, multi-threading method, I will not take a risk for going into the new thing of a Project Loom. But solution for such thing is like we can just we can do the gradual migration. Means we can just, okay, but for a particular set of services, we can implement the Project Loom or virtual thread concept. So we can just go step by step for the complete change in our application. And suppose something is new is getting built to our application, some new requirement come, so in that case we should not go with the traditional thing, we should implement the new thing with the latest technology. So here, if my application is already using traditional threading method, if some requirement coming, I will be just implementing that using the Project Loom only. So here also you can see gradual migration, replace blocking code incrementally, and use virtual threads for new components while maintaining backward compatibility. So we have to just make compatible also, because the new requirement also should be compatible with the older code only. Otherwise, there will be no use for making such code. So for monitoring and debugging virtual threads, we are having some tools like JConsole, Visual VM. So these have we have to download these. And so in now previous application, we just see by the console only. Okay, what is, how much memory is getting optimized for this. So here we can use JConsole and Visual VM, and we can just leverage the structure logs for the thread activity. Okay, uh, so if we write any program, we can, okay, this thread life is this one, thread dot minimum time, thread dot name, like this we can just put the loggers also. And metrics, number of active threads, it shows a metrics also, number of active threads, how much threads are there. With that, how the IO operations are getting performed, like means if I'm using multiple resources there, so it will be showing, okay, this much of CPUs, this much of this CPUs. If I'm having the multi-distributed environment, so this will give a number of the particular CPU wise memory consumption or details on the screen basically. So pitfalls, what should we avoid? We should avoid overuse of virtual threads, and because sometimes if something new comes, it always comes with some pitfalls of maybe we can say cons, because they also take time, or maybe bugs arises in the new things. So it takes time to stabilize all these things. So we should avoid overuse of things. And and we should just misconfigure executor, like we just take care of the misconfigured executors which are done in the thread pools, and ignore the legacy dependencies. So we have to just ignore the incompatible libraries which are not compatible with the virtual threads, that can impact the performance of the threading. So we can just avoid such thing. So these things we should take care while implementing Project Loom in our new system. And if we see the what is the future of that, of course, it is introduced in the Java 19. In the future application, if something is giving us CPU good performance, we will go with the online evolution of Java for this. And there's a better language construction and enhanced integration with other frameworks like Spring and Quarkus. So with the Spring also, I saw some APIs which are just compatible with the Project Loom. And encouragement, we should, if this thing is come in our organization also, we should encourage to use virtual thread concept rather than going with the traditional threading method for enhancing the performance of our application. Because nowadays we see there is a thing going as keep our system green, means like there should be a less CPU usage. the light consumption will be less. So there are kind of things going on where we should make applications such robust that should utilize CPU very less, and they should consume the less electricity, and they will just make environment clean basically. So these concepts are also going on in the foreign country. This has already come. This concept has already come that in a particular company, you have to give the report monthly wise, that how much electricity you are using for a particular CPU, how much radiation you are producing and how you are keeping the environment green. So these kind of reports you have to give, or if you are running in any company, then how much of data is being used in a particular day. So these kind of technology will help us to make that report better and make the use of resources in a efficient manner, as well as our application will be running in a very good way. So this is from my end. I'll show you the demo for it. Just a simple demo I have made. So, okay, is my screen visible? Hello?
Yes, Deepa,
Hello?
it is. Yes, Deepa, it is visible.
Okay. Have you slept, guys? What happened? So this in the Waba one, I've just written the function with the traditional threading method. It is a runnable task. This is a functional programming. So basically, you can see we are creating the thread. So for testing purpose, I've just created start time when the thread is starting and the end time, and at the end, I'm just calculating the nanoseconds. So if I run this program, as of now, I'm just made the simple programming. So I've just taken 50 threads, I think 100 of threads. Okay, it will take time. So you can see there are like these many of nanosecond. I think I should write down these so I can compare another one. This is for the traditional threading method, and if I just talk about the things which are done through the latest the thread pool. So here you can see what we have done. We have just enabled task, and here also I've taken 100 of threads, and here there is a executor basically. So if I run this program, there is a less difference because we have taken only okay, this is coming for the same. Okay, as of now it is taking less time because I tested it, and this one was taking 2-3 nanosecond lesser than the previous traditional threading one. So for the bigger application or multiple threading environment, it will be taking very less time for sure. So any questions as of now? Any question, anyone?
Not from my side.
Anyone, any questions?
Man, I would request you guys, if something comes up with the core Java concept, please go with the concept of virtual threads, not with the traditional threads. You will see the difference.
Yeah, Deepa,
There are
sure.
there are lots of article on Google. You can see how it's easy to implement also. Any questions, anyone? Okay.
Thanks,
Then
Deepa.
maybe
I
we can.
guess we'll take it as a no because nobody's asking any questions. So thank you so very much, guys, for attending the session. And thanks, Deepa, for the wonderful session.
Thank you.
Thank you.
Yeah. Thank you, everyone.
Thank you, Deepa.